What is up, everyone? Welcome back to another episode of Theory Premed. Theory Premed is a podcast following the journey of three premed students. I'm Todd, and I'm joined by my co-hosts Mo and Nathan. We're here to talk about our paths and our experiences as we bring in guests who connect premeds worldwide. If you're thinking about med school or anywhere in the healthcare field, our podcast will give you the ultimate student perspective. And as always, thank you to Chapman Radio for giving us a space to record today.
So let's get into our attorney.
Yes,
Bro.
it wasn't in there. Maybe they heard it. Who knows? You guys will just, if you know, you know. That's what we'll say right now.
If you
know, you know.
I hope they don't.
Yeah.
Cool.
All right, well, take us into the pregame, Todd.
So we're going to start out now with our pre-med pregame, where we talk about one thing that we learned from our classes this week. Does anyone have anything to start?
You know what? I will start because I just have the easiest slam dunk of a theory pre-med pregame right now, because we talked about hemophilia in class this week. Hemophilia is a bleeding disorder. For those of you who don't know, I have it. It's just a disorder where you're missing a component in your blood that helps you clot, helps you stop bleeding. And we talked about it in class, the fact that it's a cascade. It works as a cascade where different parts of your blood, different proteins work and come together in an order to stop the bleeding and eventually form a clot. So we briefly mentioned it. The class goes really fast, so we're going to have to study whatever the point of it was a little bit more. But I thought it was really cool that she mentioned it today, and these guys had a laugh about it. So
We had biochem today.
We weren't laughing at you.
well, they had a laugh about the fact that we were learning about it for sure.
What about you, Mo?
I think I'm going to talk about research today. So with research, the reason I'm going to talk about it is because today we are doing a research topic, and I think it would be very well fitting. So yesterday I researched some articles, found a new protocol to make 500 nanometer nanogels. Up to this point, I've only been able to go up to 300 nanometers. So super excited. I was looking through the procedures. I was kind of like simplifying them down, making them into my own. Started the reaction, and the entire solution within the flask turned into a gel. The entire thing, instead of having little nanogels.
What solution are you using?
That's bad.
I'm using ethanol and water and ammonia. Yeah, but I've literally never seen that happen. And if you go into the lab right
It's
now, you can actually
hydrogels.
see it.
Yeah.
But I think the point of this is, what I learned was, if something seems too good to be true, it probably is. Because when I was looking at it, I was like 50 milliliters of TOS, which is the polymer that we use to make our nanogels. I was like, that's a lot for the total volume of the solution. So critical thinking is important. Trust your gut when it comes to those things.
But hey, it's good that you test it out to see if it works. Why not?
I brought it up to Dr. Islam, and then he was like, yeah, that sounds great.
Really?
Like, start it.
Oh,
and I was
God.
like, okay. And then I started it. And that was because we only had 350 milliliters of TOS.
Is it expensive?
I'm not too sure how much it is. But like typically we only use 5 milliliters per reaction. I used 50, which was like, what? So critical thinking, guys, important. Yeah, that was the takeaway for this week.
Cool. I'll go to neuroscience again, probably. I don't even know. I don't know. But anyways, we talked about this week about circadian rhythms and basically like the perception of time. And one thing that I learned that I thought was pretty interesting was how, like, it's not even like really learning, but it's just thinking about the fact that certain, like, different organisms might perceive time differently than we do, and I think that that's really crazy. This might maybe allude to have you ever seen the movie about, like, it's like the aliens one where they come down and then basically like there's like these aliens that perceive time in like circular rather than linear.
What's the name of the movie?
It's like it's The Arrival.
The Arrival.
It's a pretty good sci-fi movie. But
wait, is it the one where it's like a
yeah.
I watched. I was so.
It's like a big contact
I remember when
lens.
that movie came out. I was so excited for it. Watched it, did not understand it.
Oh yeah. Well, anyways, I just thought it was interesting how, just the thought that things and even us perceive time differently. Like if someone's in space versus someone's here and someone's moving really fast, like really far away, then
time is relative.
Time would flow differently.
Yeah, time is relative. I
Physics.
think that's really crazy.
Yeah.
I'm glad I don't have to do that physics class. That'd be.
Yeah.
Yeah.
So today, if you couldn't already tell from the title or from Mo's little segue into this topic, is pre-med do's and don'ts research. And basically what our pre-med do's and don'ts are, for those who don't know, are basically we're going to talk about things that you should be doing when you're doing some sort of experience to make your healthcare or to make your journey to like a healthcare field, but also things that you shouldn't do or maybe things you should try to avoid or look out for.
Awesome. And I think a great start for this is, where do you start when it comes to research? You're coming into college. Most people actually don't even know that there's a thing called research that you can really get involved in within college. I was one of those people. I was like, what is research?
I think we all were. I had no idea either.
I mean, you started before college started,
but
right?
that was but I was like, I only found out about what it was like after I graduated from high school too.
Yeah, and then so I think just the majority of people, they come into college like, what is going on? What is research? So like, how do you even get started? How do you get involved? How do you reach out to someone to learn more about research?
Well, cold emails are one of the best ways. That's how Mo and I both got into our lab, is just cold emailing this one professor. But you can also look for opportunities in your school. I know a lot of colleges have like an introduction to the major class. We took Bio 101. And if I recall, there's a lot of different opportunities that were presented to us during that class. So make sure you pay attention to that. Write down the things that you might be interested in, and try to explore in your time in college all of the things that you might want to do.
Yeah, so I'll speak on this too a little bit. So basically, one thing that is really different from college, that's different from high school, is the fact that most, if not all, of your college professors are going to have PhDs, which basically means that they've been trained to do basic science research, or to do research of some sort. Maybe not basic science always, but they've been trained to do research and they have a degree in that. And a lot of professors are actively conducting research at universities or at colleges. And so a lot of times what can happen is if you develop a good relationship with your professor, or if you just want to ask other professors around, like maybe a professor that you've like run into a lot of times in the hallway or something, asking them, if they have space in their research lab to join, because all your professors, maybe not all of them, but a lot of them are going to be conducting their own research while teaching. So that's kind of just one other path to look for as well.
Yeah, exactly.
Totally. And a lot of those qualifications that they've kind of been taught to do, like conduct research, right? That gives them the qualifications to apply for grants. So a lot of those professors have thousands of dollars, if not even hundreds of thousands of dollars, to conduct the research. So there's even opportunities for you to do research, get that on your resume, develop as a scientist in your field, and get paid. And I think that's a lot more common at bigger universities, especially UCs. I think we could all speak on Chapman. It's very easy to get involved in research if you really want to.
Yeah.
I know for myself, when I went to get involved into research, all I had to do was email professors. There's an entire website with different schools, the different professors in that school, what they're doing within their school, what type of research. And then you could just simply email, be like, hey, I'm interested in this. Could we set up a meeting? And that was pretty easy. I think every single professor got back to me whether it was like a yes or a no. Usually if it was no, it was just because there wasn't enough space in the lab. But 90% of the time, if there was space, I was given that opportunity to talk to the professor about the research, get to know it. And I think that's really important. Don't just jump into something without really asking those questions, because you want to make sure that you're successful in that.
Yeah.
And I mean, each person is very specialized in a specific thing. So you really want to make sure you're interested in that. But there are times where you might take on something and it might not work out. That's totally fine. Don't feel like you have to commit to that thing for 4 years. If you try it out and it's not something for you, don't let that stop you from trying out something else. I think that's the biggest thing. But I want to talk more about what Ethan's experience was with this, because he goes to a bigger university where it was a lot more difficult to get into a research lab. My biggest advice for him was to just cold email people in his university. He ended up doing that and then got not that many responses, to be honest, but he got some. And with those, he was able to just show his interest. But what he realized was, when it came down to those professors that gave him the opportunity, what gave him that next step to getting an interview for that research lab was showing specific interest within the different articles that were published by that professor. Because that showed that he wasn't just saying, I want to do research. It was saying, hey, I've looked through your work and I found these certain points very interesting, and I want to learn more about those. Yeah. And that was what took him to the next step of getting that interview.
So You
Good
talked
points.
about cold emailing. Do you want to just quickly define what that is for people who might not know?
Yeah, cold emailing is just literally finding something, for, in this case, research, and just sending out an email to that professor or that person, being like, "Hey, my name is this is who I am. I'm interested in what you're doing. Could we please talk about it?" That's really it.
Yeah. So what really makes it like that cold email is the fact that like you might
You
not
don't
be
know
yeah,
him.
like it might be a
You don't
professor that
know them.
you have never met before.
Exactly.
It's just
Exactly.
an email that you find. So yeah, that's one big do is just look around, ask around, go to school events if they have panels or anything like that. Utilize maybe the people that you know, maybe you have friends who are doing research, ask them if they know of any opportunities. Cold email, basically, get involved and ask around.
Yeah,
Mm-hmm.
and
So
don't be
that's the first big do.
discouraged. Don't be discouraged if you don't get a response. That happens. Like, who cares? I think going into it, you just have to keep in mind that there is a very good chance you're going to get a no. That's fine. I mean, you're still at the start of your career. You don't have that much background in research, so really just try your best and send out those emails, and whatever happens, happens.
Mm-hmm.
And if the worst case scenario, you just practice introducing yourself to someone that you've never met.
Yeah. So next, for things that we should do, right? What are things that we want to do in research? But not only that, but what sort of opportunities do we want to have? Like, what specifically do we want to be doing when we're in a lab, or like, kind of like I guess if we analogize it back to like the hospital volunteering, is that like you want to look for direct patient contact, right? What's that sort of equivalent for research in a way?
I think research really gives you the opportunity in the lab to take the things that you've learned in lecture and your kind of like lecture lab type setting and really bring it to something to the front of that specific topic that you're looking into. And I think a lot of the skills come in, and you'll realize very quickly that there's so much that you don't really understand and know about. And that's where you need to start reading articles. And that's how you progress your critical thinking and your understanding of science. Because those articles are so difficult to read at first, and then it becomes easier the more you read it, at least in my experience.
Yeah.
So I think the biggest thing is you just want to develop your critical thinking skills and your ability to take a certain piece of information and build off of it.
Yeah.
I think it's not an exact equivalency to the volunteering, because the volunteering is something that, like, medical schools are looking for patient contact, right? They're looking for this type of thing. But research, there's such a wide variety of ways you can do research, or different specialties or interests you can get involved in. So it has a lot to do with doing the thing that you're interested in is something that I think you should look for, and something that you can talk about in a medical school application, in get published even, and talk about your experience researching. So I think it's less of an equivalency, more of just a general, you want to do the things that you're interested in and you can talk about and show that you're good at.
Yeah, and honestly, what I was kind of like trying to ask with that question, and Nathan was talking about it a little bit, but basically it's just that you want to be in an experience where you're in a position where you can ask questions, where you can ask questions and then do the research to try to find, answers to those questions, or be involved at least in some way of that, process of asking a question, collecting the data to answer that question, and then analyzing it. Whether that be you're doing it all by yourself or you're doing it, with assistance of a group. That's the kind of experience that you want to be looking for, rather than something, and this was kind of like what I was trying to say with like the non-patient contact, is you don't want to be in a position where you're like just washing flasks or you're washing beakers all the time. Kind of like our joke in OChem lab last semester where we made Nathan wash all of our things. But basically, yeah, so you don't want to be, if you can, try to avoid things where you're just washing things and you're not really participating in actually like the asking questions or like the intellectual intellectual side of things.
I don't think it just has to be washing dishes. It could literally be, you could be given the procedure and be told to do it. I think that's still very uninvolved. I think going back to what Todd was saying is you want to be at the forefront of that research. You want to be able to say, I thought through these problems that the research was having, and I helped in developing like a fix to it. Mm-hmm. And this is how we've been able to progress it. Because I remember my first lab, it was more like I was given something and I just had to do it, and it was repetitive work. And I think at a certain point, like, yeah, you do your first 100 hours through it, But after that, it's like you don't really have a connection to that research. You're just coming in every day, doing the same thing, being told what to do, and you don't really learn as much. But with our research now that both Nathan and I are doing is we come in every day, we have a certain problem that we had the last time we were in, and we're able to kind of build off of that and try to find solutions. And I think that just helps you grow as a researcher too.
Not only that, but it's the thing that attracts me to the research, the ability to use critical thinking and not be completely dependent on the instructor or on some type of procedure. Or not just being on the side, as an assistant. That's what's really kept me, kind of going in the lab. So
it's what brings you back the next day.
Absolutely.
Exactly.
And honestly, though, but the thing is, and I'll kind of like counter argue a little bit with that.
Yeah, definitely.
Like, because honestly, I feel like you guys have only really, I mean, actually, maybe not Mo, but I think Nathan, you've only kind of been in a position where you have been like leading your own project.
Well, yeah. Mo had a previous research where he's giving his
own. For me, I've been on both sides, and I started out being, helping with a lot of the data collection with a certain project. And honestly, like, I totally get what you guys are saying, and I do agree. But at the same time, I also think that there's pros and cons to both, because when you're being kind of like led, or you're being assisted, or you're working in a group, you're allowing yourself to learn a lot more, to ask a lot of questions about, why are you doing this sort of study? Or like, if it's a complex study where you need a lot of data, it's like, okay, why are you collecting this data? And like, you're able to think critically about it from that standpoint. I think that you can think critically about why you're doing such research, or kind of like, for example, I had a project where I was working on it for a long time, but that was like kind of what we were explaining about under a certain like a person or a different person's like question. But I was able to like think critically about that project and kind of create like a little subdivision off of it, right? And I think that that's sort of the things that are really beneficial, rather than just doing it and being passive in it. Right. I think that there's a difference in like taking active learning and initiating things, like asking questions or learning about the research process and why all these things are occurring, rather than just sitting there, and just kind of going through the motions. I think that there's a certain distinction between that. And I think that you can do both, whether you're leading your own project or you're part of a group working on a group project.
Yeah, exactly. Being proactive no matter what position you're in, it seems like a very useful way to spend your time. And one point more is, somebody might not have access to the type of lab where they can critically think, they can lead their own work. So being able to get the most out of those experiences where you're more of an assistant is definitely beneficial. So really good points there, Todd.
Yeah, I mean, even then, I don't know if I'd really consider like assistant, but either way.
Oh, really?
Yeah, either way, because I mean, it's like a group. It's a group work.
Yeah.
But basically, one thing is that we're really lucky, especially at Chapman, to be able to have smaller research groups where you are in positions to like lead your own projects. But I think a lot of times what might happen, and this is totally varying between labs, is that at a lot of bigger schools, there's going to be bigger research groups, which will have more people who are like PhD students who are going to be leading their projects. And so I just really want to capitalize on the fact that it's okay to like start out kind of smaller and working your way up, and you don't because you're not always going to be presented with a case that you're going to be leading it right from the start, if that makes sense.
No, that totally makes sense. I think the biggest thing is you want to make sure there's room for growth within that lab. You don't want to just kind of go in there and just kind of be guaranteed to stay in like the lowest possible position for 4 years. But like obviously you want to be able to, you have to learn some way, which is starting at the bottom. But eventually I think you also want to make sure that you're able to progress within everything that you're learning. Because if you're stuck at that one spot, you're going to reach a point where you're not learning as much anymore.
Yeah. It's just wherever you are, like always keeping an active mindset of taking initiative and learning things and asking questions all the time.
Totally. And that's what all research is. It's being proactive and constantly putting yourself out there to learn more.
Yeah, and asking questions for sure. I mean,
ask questions.
All of research really is hypothesis-based questions,
And it does interact with what you're learning in class. I mean, Todd, do you want to talk about like the blocking system that you use?
Yeah, I mean, honestly, like my way and the way I've progressed about things is a little bit opposite, I think, from what maybe Nathan's referencing, because...
Well, no, I just want to hear about your experience in it.
Yeah, no, for sure. But I think for me, I learned about a lot of these techniques before I came into classes. So like I learned a lot about what's called immunostaining, and that's what I do a lot of, which is really similar to a Western blot, where you use antibodies like the immunoglobulin Gs, and basically you just have those bind to specific proteins, and that's kind of how you're able to measure protein concentration or like the presence of proteins. For me, though, what I learned was I kind of learned things in reverse because I've been in the same lab since like my freshman year, and I had to learn a lot of things on like kind of before I reached them in classes. And what's kind of funny is that I've been learning a lot of the things in like biochemistry and in neuroscience this semester, which is kind of funny. But I think a lot of people go kind of in reverse, where they learn a lot of things in their classes and then they take it to research to apply it.
Yeah, I agree. And whichever one you do last really helps to clarify your learning. I mean, it was interesting to me how you had like basically done Western blotting before and or like the blocking.
Yeah.
And in office hours, you asked a question about like some very specific detail of it, and the class and the professor helped you answer a question that you had during research, and it can be vice versa. It can be questions you had during lab answered by research, or in class answered by research. So, but yeah, interesting points.
That's what makes research so cool, though, because you're learning so much that other people don't know about. And it sometimes can give you an up in lecture because you come in, you already have a pretty good idea of it, which in this case Todd did.
Yeah, except it wasn't asked on the exam.
Yeah.
Yeah, that's
So
also
sad.
true. Nothing about that on the exam at all.
Yeah, and I'll bring this quote back up again. And this is something that I've probably said a couple of times already, but I think it's really specific or pertains to this episode really well, is that when you're in your classes, in your lectures in college or in high school even, that is teaching you a lot about what science is. It's teaching you about, this is that, these concepts are this. But then when you actually get into research, and why I think research is such a vital source of education for anybody who's in science, whether you're going to med school, whether you're, no matter what career you're going into, why I think it's so vital for science is because research teaches you a lot about how to do science, like how science is conducted, how these things are found out, and really kind of like how the whole process takes place. So that's kind of something that I learned my freshman year that really stuck with me, obviously till now.
If you want to learn more about that, check our last episode. We talked about that a little bit and some of the pros and cons of research in general. But yeah.
So we've talked about cold emailing, right? Reaching out to your professors at your school. Now you're in that interview process. What type of questions do you want to make sure you're asking? What are some things that you want to make sure that you're able to what are some expectations that you should have for that research? And what are some expectations you should expect the professor to have for you?
Yeah, so that was like a pretty multi-pronged question there.
I think you could include it all.
No.
Yeah, but like
good soup.
I think for in terms of asking questions, just ask literally like anything that comes to mind, right? Whether that be, how do I do this? Or why am I doing this step? Or what is our research about? What is this part doing? Or something like that. Like just literally any question you have, it's all supplemental to your learning, and it's all just really great.
Any question shows your interest.
And I think why it's so important to ask all those questions, even if it might seem like the most random thing ever, is because that professor gets to know you better through those questions. And they could possibly give you a side project that they're interested in for you to focus on that might kind of better align with your interests.
Yeah, and even just one thing that I want to mention is that as scientists, I'm pretty sure all three of us can relate, like all scientists want to do is just like talk about their research, and having someone who's asking about that is like the number one thing that they want.
Yeah.
So don't be afraid to ask those questions.
There's gonna be times where you ask a question, you're like, oh my God, it's been 10 minutes of that person answering the question.
Because sometimes I'm like, oh,
Such a good
do
point.
I want to bother this person with this question? I don't
They
know.
always
and then I
wanna
ask
talk
it,
about
and
it.
they're like, oh yeah, I'm so happy to talk about that. I'm like, oh, sweet. All right, cool. So yeah.
In at least my interview with Dr. Islam, or interview more like he was just trying to figure out if I was interested in the lab. I mean, he was really, really good at explaining things, and I just kind of really became interested in what he was doing. I asked a lot of questions. But you know what? The thing I liked most about it is how excited he was to talk about it. I think his excitement, and I've seen this throughout working with him in his research group. Every time we make like some discovery or some problem gets solved or, you know, something like that, he gets so happy and it makes me so happy. So something like that, you know, these professors really want to, you know, talk about their research and they love what they do. So
I mean, they devoted their whole lives to it.
Obviously,
you know?
yeah. So talk about it with them, and you know you should be easily getting into most labs, I would say.
The other thing is, like, it can be really intimidating, I think, to ask these questions, and especially because like every single lab has its own vocabulary, in some ways, because research is so like specialized. I feel like you talked about like your TOS, which is like your. Remind me again, because I forgot.
TOS is like a polymer.
Yeah. So, and then I have like vocab that my lab uses that obviously is very different from Nathan and Mo's.
Just the culture.
Yeah. And so don't be afraid to ask those clarifying questions.
And I think just going back to the expectations that you should have or should look into possibly exploring, I think the biggest thing is you want to make sure that you're able to learn. I mean, we've touched upon this earlier, is you want to make sure that the professor is going to be there to help you out whenever you do need help. Obviously, certain schools might have different kind of student-faculty interactions or like the extent of student-faculty interactions compared to Chapman. But I think one thing when I got into Dr. Islam's lab that I really wanted to ensure I had was that his support. I wanted to be like, hey, if I'm really struggling with this, I could come to you and talk to you 90% of the time. Yeah. Just because I think that helps you go through your project a lot faster. And just learn and progress a lot faster. Mm-hmm. Because if you don't have someone like who's constantly able to help you throughout the process too, it's very easy to get stuck and be discouraged. And I think that's just something in research you have to look out for.
Yeah.
Yeah. And going back to what you were saying about, you know, maybe what the professor should expect from you. I think it's definitely just kind of like like not necessarily like a hard devotion, but just a devotion to, you know, the work. You know, you want to be there when you're supposed to be. You want to be doing the work in a timely manner. You want to be, you know, helping out, being curious, being able to ask questions, and really being able to, I guess, like think critically. I think is like what is expected.
I think one thing about research is you have that question you're asking, and you're working on a project. And something I've noticed about myself is I'll always have that idea in the back of my mind, and things will come out throughout my day, and I'm like, oh, that could possibly connect to my research. I could possibly have like an application built into this new thing that I'm learning about right now. And I think that's how you become part of that research.
Oh, yeah.
And I think that's an expectation a lot of professors want you to have. And yeah, I think showing up is the biggest thing too. You don't want to be that person who comes in 1 week and just disappears for 3 weeks, comes back for a day, then disappears for 2 weeks. Nothing's going to happen. I mean, right now I'm doing like 10 hours a week. I'm barely able to get anything done. Research takes a long time. And if you're not able to put time into it, it's really hard to progress in it.
Cool. Yeah. Yeah. And then one more thing, and we talked about it a little bit, is about the idea of reading scientific papers. And I think I can definitely talk about this, and you guys can all probably talk about it too, is the fact that when we first got here, like as freshmen, research papers were so intimidating and they were so difficult to read.
I think they still are, but
and
most of them are.
Yeah, and we definitely have done so much work in terms of reading those
Definitely.
and learning how to process those. And I feel like, honestly, right now I don't really have too much struggles with them. I feel like I'm able to read passages and I'm able to derive like the meaning from them pretty well. I mean, or I could just be like off the compass totally and just be getting the wrong meaning every single time.
They're hard. I mean, they don't scare me anymore, that's for sure. Yeah. But like even the one that Dr. Shu gave me for Denated Dinosaurs, it seemed like a simple, you know, evolution paper, but some of the, you know, the charts and graphs and stuff you haven't seen before. It takes a long time to kind of decipher what everything means. Even if you read through it once, you might have completely missed the point of it. Mm-hmm. So research does give you that practice of reading through these research papers and trying to understand. And of course, the more you read, especially about one topic, the more you can understand. So I think that's a great benefit to it.
I mean, like everything, I think it just comes with practice. Over time, you're gonna get the hang of it, and I think that just what makes it so. At first, it's scary, but then over time, it's not as scary anymore. But I think what kind of makes it difficult to read time after time is the language and vocabulary used. I don't know why people do this, but a lot of the time, like things are very like specialized in the field, so it's very difficult for someone who's starting off in the field or is trying to learn more about the field to really wrap their head around it.
Yeah, and I think that just kind of going back to like asking questions, you should be reading as much as you're asking questions. I think it's kind of like two sides of like the same coin, where it's like you got to read a lot to understand things, and you got to read a lot to ask good questions too. But yeah, do we have any specific methods for attacking these long papers?
I'm guilty of this, and I'll honestly, a lot of the time, I'll read like the first paragraph, and I'll just jump to the results, and then go back and forth. I don't know. I just feel like sometimes like you'll read through the full introduction and all that stuff, and you'll be like, okay, like I don't care, whatever. And then you'll go down to the results, and that's like what you really want to look at. Like for example, this previous article that I used to make my nanogels and the procedures for my nanogels. All I cared about was what is the size that they made and how did they make those sizes. Right. And then once I figured that out, I was like, okay, I want to make TOS number 3, TOS number 4 because those are the sizes I want. Now, okay, I see these are good. Let me go back into the discussion, the methods, figure out how they did that. Mm-hmm. So I think a lot of it for me just makes more sense when I could reference it to some like a physical like data. But I think that's something you learn as you read more and more papers. You kind of figure out your own system.
One thing that I do is, and I think if you're really trying to understand a research paper, go to the figures. At least try to understand every figure. And if you can do that, generally, you're going to understand the whole paper. Because if you understand like the results of what the figures are showing, what they're meant to show, then oftentimes you get the point. So that's a good tool.
Yeah, and I think one thing that I've heard a lot about what's really popular, even amongst like people who are at like the tops of their fields, is that a lot of them sometimes will just read only the results section and not even care about like the other ones. I mean, they'll read results and then probably methods just so they can see how it was done. But things like discussion, like they won't even read because a lot of times discussion might come down to like opinion.
Exactly, totally.
And so they just look at results and methods and maybe some of the intro, if there's some background they don't know, and kind of just go on from there.
Yeah, it's definitely a different way of reading than you're used to, that's for sure.
Yeah. For me, I think something that's really helpful, especially if you're trying to comb through the whole thing, is every single every single abbreviation you encounter, you want to just like start like a Google Doc or or like have a piece of paper and write down what each one means, because they're only going to say the full term once and then have the abbreviation next to it, and then every single time it's referenced throughout the rest of the paper is going to be just the abbreviation. Yeah. So having a shorthand of every single abbreviation is going to help you like immensely. And I think that is what is really intimidating about research papers.
One of the things.
Yeah, because once you get those acronyms, or you'll look through the paper and you'll see all these different abbreviations and you'll be like, I have no idea what any of this means. But like some of it could be super simple and you just haven't looked at it, what the full word actually means.
Yeah, that's such a good point. I've definitely like gotten so confused just glancing through everything and seeing a bunch of abbreviations and then just like giving up basically. So
yeah,
a Google Doc's a good idea. You could just keep like a little notepad next to whatever you're writing. If something seems to be important, just write it down. That's pretty good.
Yeah. I mean, I think in general, from everything that we said, it's very clear that it's a completely different approach to reading when you're reading an article. It's not just starting at the start and ending at the end. It's a lot of like jumping around and trying to connect things and finding what really interests you and what matters to you, and really just focusing on that and trying to build off of that.
Yeah. So it's tough, but it's worth it if you get a really good paper and you understand it and you feel like you can get something out of it.
Totally.
So
yeah. One last thing that I want to mention about reading papers is, sometimes it kind of depends on how in depth you want to read about it, but sometimes it's okay to like like not understand every single thing. It's okay to let go a little bit.
Yeah.
Because sometimes if you're just reading a certain passage, you might be like, okay, there's this. I don't really know what that does, but it sounds like this is causing, whatever this is. Like this is causing a change in this.
You will waste so much time if you try to understand every single thing. You have to move on.
Yeah, so sometimes
get the main points.
Yeah, you can just kind of get like a general scope or general understanding of things if you sometimes just give up a little bit in terms of like, okay, I don't know what like this like supraventricular optic like this thing is, and just kind of saying, okay, well, I don't really know what this is, but I do know that this, whatever this is causing this sort of change, right?
And if you think about it, that makes sense. That paper has been written from probably years of research and kind of learning things, and they've condensed it into one paper. It's not going to be the perfect research paper, but it's just you have to take the most you can out of it and then just build off of that. Yeah. But we've talked a lot about the do's of research. What are the don'ts? Let's switch this up a little bit.
Yeah. Okay. So I don't know. I know I have a pretty good story for this one. I also probably have said it before, but the idea of don't be afraid to make mistakes.
Also,
right?
Don't make mistakes.
And I think when you make,
no, I'm just kidding. Don't be afraid to make mistakes.
I think don't make don't make don't be afraid to make mistakes. But when you do, like, tell someone about it.
Yeah.
The last thing you want to do is if you make that mistake, you don't want to just kind of brush it off and build everything off of that mistake. Because that mistake could be very detrimental to your research and it could cause very different results. So if something does happen, just fuss up about it. It's okay. Tell someone about it, and let's say you get some attitude for it. Okay, oh well, that's for that day. You learn, you live, and move on. No one's gonna hold it against you for the rest of your time in the research lab.
Yeah. If you make a mistake, just don't be afraid to own up to it.
Yeah.
Right. I've made mistakes. I feel like all three of us have made mistakes at some point, and every single person too that is instructing us or supervising us has also probably made a mistake at some point. Right. It's really unrealistic to expect yourself to do all these things that maybe some people have never even done before or never even looked at before. And to expect yourself to never make mistakes is just a little like unrealistic, as much as we would hope that
we all have our off days, and there's gonna be times where you're in there and you're on autopilot in a way. And things might happen. But I remember like when I broke the 3-neck flask, I was writing up that email and sending the picture.
Tell a story. Tell the whole story.
Okay, so I was
Oh
I had just finished my reaction. We literally have one 500 milliliter flask, and that's what we run all our reactions in. They're pretty pricey.
So wait, what does it look like?
It looks like the bottom of a cow. You know the bottom of a cow where you milk it?
An udder?
An udder?
Such a weird comparison.
It literally looks like that.
I guess it does, but like you could just
that.
say it's a round bottom flask, but it has 3
Oh, I just
necks.
call it the cow thing.
What's it called?
It has 3 necks.
Three neck, round bottom flask.
Yeah.
So
that's exactly what it
okay.
is. Yeah, you just look that up.
Doesn't it look like it?
Oh my gosh.
Yeah.
That's exactly what it is.
So anyways, I just finished my reaction.
These are really, by the way, let me just preface this. These are really important things to what Mo and I do, because it's the thing that you do the reaction in. Like the microgels or nanogels, they form in those 3-neck bottles. But go ahead. Sorry, go on.
So
we have 2 of them.
Just finished it, and they're not the same size either. There's one that's 250 and one 500.
Okay,
and
so this is pretty big.
Yeah, so 500 is like about this big.
Okay.
And that's the one we mainly use. So I just finished my reaction, dumped everything out, ready to go home. It's like 7 p.m. I've been at school since 8:30 a.m. So start washing. You have to wash everything very quickly, and it has to be done very well, or the gels will just stick around and that flask is ruined. So I start cleaning. I'm brushing it. And since it was just in a hot environment, it was at 78 degrees Celsius. The second I put water on the inside, all I heard is
that was really good sound.
And then
oh my gosh.
I just looked down.
How did you do
And just the side just had the biggest crack. And I was like, you know what?
Yeah.
I'm just going to keep on cleaning. And then kept on cleaning. And the second I scrubbed against that surface, and another just destroyed. I looked at it and I was like,
shattered.
I looked at it and I was like, it's 7 o'clock. I could just go home and just deal with it tomorrow. But took a picture of it, sent an email, and I think the biggest thing is you have to show that you understand what you did wrong.
Yeah.
And you just man up to it. And I mean, my professor was super nice about it. He was like, "Don't even worry about it. Just make sure everything's cleaned up, no glassware is in the sink or anything like that, and we'll figure it out whenever we do." And I think he's
really
ordered
nice.
new ones. Again, like every lab has.
We needed
money.
more anyway. I mean, it was just a
Yeah,
good
yeah.
excuse to buy them.
Exactly.
So,
So yeah,
you know,
every lab has
really-
extra money laying around, and that one flask breaking isn't going to be detrimental to research.
Yeah.
What will
It's not like it
will
costs
be
$1 million.
detrimental is if I didn't say anything about it, and a week later he wanted to run a reaction, or Nathan wanted to run a reaction, or Natalie wanted to run a reaction, and they had an entire plan, and they come into the lab to find out that we don't have a flask.
Yeah.
So I think that's just the biggest thing with that.
I could just imagine, like, what if you take it, like, it's just like in pieces, like in the sink. You take a picture, you be like, is this still usable? I just imagine.
So we learned that you shouldn't take
They
really
tape it
hot
together.
things and put them in cold water
Exactly.
right away.
Yeah.
It's
So-
happened multiple times.
Yeah.
And I think the biggest thing with like just manning up to your mistakes
Yeah.
is like you could tell which students are in research just because of this in a way. Because in lab, for example, just the regular class labs, the people that make mistakes and they're like, oh, whatever, like I just want to leave lab. Those are just most of the students that they do. But a lot of the students that are involved in research, they restart and they just do it again. Like I remember when we messed up in our biochem lab. Or I messed up. I messed up. Okay, I was on like 2 hours of sleep that day, and it was like 9 p.m., 9:30 p.m., something like that. So I could have easily just been like, I'm not gonna say anything, and we could have just moved on with it. But
No, well, I was because of me.
okay, no.
Wait,
okay.
how could you
Well-
not say? Don't you have to produce a graph based on your results?
Yeah, but like, it was still the same proportions in a way. It was just 600 microliters short.
Mhm.
Of
each
enzyme.
tube.
Oh.
Of enzyme.
Of enzymes.
Oh.
But it matched the previous weeks. In the previous weeks, we got good results.
Not for one of like the
We
standard-
did. I think we did.
One of the curves was straight, which
Oh,
it
was it?
shouldn't have.
Anyways, I was like, Todd, let's just like keep it going. And then Todd was like, no, we have to restart. But we just restarted. I mean, I knew in the back of my mind that we would just restart.
Yeah.
Because I was like,
Yeah.
it literally took 20 minutes to do this. An extra 20 minutes is gonna kill us.
Oh, really?
Type of thing.
Yeah, but then
Oh, I was gonna say, because didn't you guys get out like
And we
2
messed up
hours
again.
late?
And I messed up again, I think.
Okay.
Yeah. I messed up again.
it's all right.
The temptations were high.
Yeah.
I'll say that much.
No, I've been there. I've been there.
Do you have a mess up story? A mistake story?
Most of my mess ups were in our OChem 2 lab, I think. Didn't like what happened?
A lot
didn't we
happened.
like one of our first
Turned on
okay.
the air instead of the vacuum.
That was one of
Oh
the
my
big
God,
ones.
that was
That was one
terrible.
of the big ones. But that was Mo's hands doing it, so I don't
What?
take
No,
full
no,
credit.
no.
All right,
Yeah.
as we can see,
Oh, wait.
they
Oh,
still
sorry,
have not
my bad.
resolved it.
Okay.
Who turned the? Okay, I might have put in the air tube, but who turned on the air?
He put
Who turned on the
it
air?
was supposed to be a vacuum.
Who-
Hold on. Let's
turned on the air?
Let's rewind a bit.
Who turned
You
on the
put
air?
the vacuum you put the air going in tube into the the little thing vent where it's supposed to have the vacuum.
Okay, but who turned on the air?
I think I turned on the air, but
You
I'm
did
not
turn
sure.
on the air. You turned on the air.
I think it's a combination of faults here.
And it blew up. It blew up, and it was really
Well-
stupid, and we were depressed, and then we did it again because we're research people. So I guess
Well,
you know.
yeah, we just can't use blown up results now. Can
Yeah,
we?
that's all true.
Yeah.
And then another time, Mo handed me like a burning test tube, and I touched it, and it was
that
bad.
one was kind of funny.
That
You guys got pretty mad.
in the moment, it was. I mean, it was a little funny.
Nathan like started like throwing hands. And then
bro,
they,
I
like-
was
He gave me
totally
a
chill
black
about
eye.
it.
He literally gave me a black eye.
I could have been
He
a lot.
punched me in the
all right,
lab.
I could have been a
was
lot more
physically
upset.
assaulted
No,
in the lab.
We're just kidding. We're just kidding.
I could have
I had
been a
a
lot
black eye.
more upset about it, but I was super chill. So you guys gotta let me go on that one.
Okay. Anyways, so I think it's very clear. Like mistakes happen. It's okay. Like just live up to it. It's whatever. Learn from it. Move on. And I think another thing is don't give up. There's gonna be a lot of times in research where you're gonna reach a point where you're constantly doing things and nothing's happening, and that's okay. That's part of the learning process. Figure out why things aren't working. Figure out what are some things that you could be changing. This is a time where you have to do a lot of reading to figure out what other people did to make results appear. And then kind of build off of that. Because I think if you're watching the video of this podcast, the way research is at first you're learning a lot and a lot is happening. You're going up. And then you're going to hit a point where things just plateau. And there's going to be a time where you're like, okay, I have to take some steps back start going back down. And then you're going to learn a lot more during those steps back down, and you're going to go up higher. And it's just constant down and up, down and up,
Sure.
down and up.
Yeah.
And it could be very discouraging at times, but it's all about what you're learning, all about what you're able to come out of that day with, and the questions that arise from it. Yeah, I think that's all I have for that one.
Yeah, there's a lot of highs and lows. Like it's definitely like a roller coaster, because you could have everything. Well, everything is a hypothesis. Everything's a question, right? You don't know the answer to it. In fact, no one knows the answer to it. Probably no one in the whole world. And even if your question or your hypothesis makes total logical sense in your mind and based off of everything that you know, that doesn't necessarily always mean it's going to be true. And the fact of the matter is that even if it's not true, just don't let it discourage you, because the lows might be low, but if your question's right, and it will be eventually, eventually hopefully you'll have a right question eventually, and you'll be able to find something really cool and something that you find really important. Once you actually find that thing out, you're gonna be happy. You're gonna have that high that will make all the lows disappear. When you finally see, the thing that you made, or the thing that you have been asking for, been looking for so long, it'll be great.
And another thing I want to add on to that is negative results are not bad results. And what I mean by that is they can be very important in understanding what you're trying to do. So if something doesn't go right, you want to keep those results. You don't want to just disregard them, because that could be an indication of what is wrong with your procedure. What are some things that could be happening? And that could kind of change your approach on that research. So you don't only want to keep the good results, the ones that prove you right, but you want to keep the ones that prove you wrong. Because when you look back at it, you're going to be like, hey, these are some things I've changed because I got in those results. And by doing that, I've gotten these really amazing results.
Yeah. Absolutely. I mean, I've been getting hydrogels in almost every single thing for my microgels, so I'm gonna have to kind of backtrace and figure out how to eliminate that. So, that's another project, but we'll see.
Yeah, and that kind of plays along with don't give up when you make a mistake. Don't give up when you don't get the results that you were hoping for.
Yeah. And I think a lot of the time there's a confusion between giving up and not being happy. If you're simply not happy in the lab just because of the environment you're in, maybe the project that you're doing is not very interesting anymore, it's okay to take a step back and try something else, another project. That's not giving up. That's just simply realizing hey, this is not for me. This is not what I expected to be doing when I first joined the lab. And I want to explore something that I'm more interested in. And if you think about it, when you come into college, let's say you start research your freshman year, your interests are going to grow by a lot. You're learning so many new things. You're starting off with Gen Chem, Gen Bio, then going into genetics and OChem. You're learning so much new material that you didn't even know existed. So your interests are going to change, and that's fine. Embrace it. And if you find another lab that you're going to be a lot more kind of successful in, and you find yourself staying in that lab longer and just really enjoying your time and making better progression and things like that, it's okay to take that step back and join that lab. You're not contracted to stay in a lab, and that's fine. And things might happen where you started off in a volunteer position at one lab, and you might be offered a paid position in another lab. That's okay too. Yeah. At the end of the day, we all need to eat. We all need to live. Yeah. Right?
Really important point there. Difference between giving up and just moving on, not being happy in a research lab anymore, and continuing somewhere else. So that's really important for pre-meds to understand as well, because you want to have as much experiences that you want as you can.
Totally.
And
I know we've talked a lot about results, and it's super easy to just get caught up in the results and wanting to get results, but that's not all research is about. It's you're learning so many different things, and at the end of the day, you're building skills, and a lot of that comes to communication skills, teaching skills, things like that. And there's a very wide range of different branches that you could kind of enter using research. An example for that could be talks that you could be doing, poster presentations you could be doing, your writing, whenever you're writing procedures, whenever you're writing manuscripts, things like that. So don't just get caught up in the results. Really focus on all the potentials of research. And I think that's what really makes it beneficial at an undergraduate level.
Yeah.
You're not here like, yeah, publishing is a very big thing, and if you're able to do that, congrats. That's a very nice bonus to have.
Yeah.
But that shouldn't be the ultimate focus. You're an undergrad. You're not going through graduate school yet. So really just build those skills now. So when you do enter graduate school, where you're being funded to do that research, where you're being given thousands of dollars to do that research, you have those necessary skills to make the most out of that money.
Yeah.
Yeah.
And then your goal can be to get published.
Exactly.
Yeah, and I want to take like a little bit of a step back and going back to like the like making sure that you're happy in the lab that you're in is just the idea that oftentimes I can hear that one person might not have a great experience in research, and they would be like, dang, I don't like, maybe research isn't for me, maybe just, or I don't like research because of one experience they have in one specific lab. But one thing I really want to capitalize on is the fact that every single lab has a different culture, and your experience in research can be vastly different between labs.
Totally.
Yeah.
100% agree with that.
Cool. Well, does anyone have anything else to add?
Well, we have to do the most pre-med thing.
Most pre-med thing to
Things,
say.
How many publications do you have?
Oh, that's like
0.
most pre-meds don't. So.
Yeah, it's a good point.
Yeah. I think that's like a lot of people ask that.
I
don't know.
Yeah.
Do you have any publications?
I have
gotta
0.
restart.
Oh, I gotta restart. Messed up. Yeah,
Yeah.
that's pretty good.
Yeah.
Like, I gotta do it again because I messed up this one tiny little thing. I gotta redo the whole thing.
Yeah. Okay, cool. Well, we'll wrap it up now. So for those who don't know, Theory Pre-Med is on TikTok, Instagram, YouTube. Check out our videos and check out our podcast episodes every Tuesday at 8 a.m. Yeah. And so thanks everyone for joining us. Thanks for listening. And we hope you have a great day, and we'll see you later.